Hi there! In today's video, I will show you 5 different use cases for the new GPT-4 Vision API. So the first use case is image categorization, which is kind of an obvious one. But basically, I have a bunch of images in this images folder here that I have downloaded from unsplash.com. And I would like to find from these images the ones that contain dogs, for example. Now, of course, I don't want to go through all of these because you might imagine that I had hundreds or even thousands of images. So what we can do is we can write a quick Python script that loops through all of these images and then sends them to the GPT-4 Vision API and asks it to create a comma-separated list of the keywords that describe the image. And then we just save those keywords to this image data.json file. So it will have the image and the keywords. So basically we are indexing these images with GPT-4 Vision. So let's do it. So let's run Python 3 image categorization.py. And right now we are going through all of these images. And this will take a while because for every image we have to make a new request and it takes a few seconds per image. Alright, and it is done. So now I have another script here, which is image search.py. And basically this opens this image data.json and then asks us for a search term, and then it will loop through all of those images and their keywords, and then it will print out all of the images that include the keyword we search for. So let's see if this works. So if I say Python 3 image search.py, then it will ask us for a search term. So let's say dog. We want to find the dog images. And here we have it. We have 2 images. So let's open these. And that is definitely a dog. And let's open this one. And that is a dog as well. So let's try to find something else. I remember that there was a mountain climber in one of the images. So let's search for mountain climber. Now this only checks the exact keyword. So let's see if we can find it. We cannot find it. So let's actually search for mountain. And we still don't find it. So maybe this was a bad example. Maybe it is called cliff. Okay, perhaps this is not as good as I expected. But at least we should have a pizza. And here we have a pizza. Now let's also search for a motorbike. And here we have a motorbike. And this image contains a motorbike. And let's actually see what keywords it used for the mountain climber image. So we have somewhere a mountain climber. So what is this called? Let's check our image data. And it was 85EY. Okay, we have a climber. And we don't have mountain, but we do have rock formations and canyon. Now, like I said, this only checks the exact keyword. So, of course, we could use ChatGPT or embeddings or something like that to make it find like related terms. But let's try one more time. Let's say blueberry, because I saw a blueberry on some pancakes. Well, that is a bit disappointing. Blueberry. It is actually blueberries. So one quick thing I could change here in the image search is that I could do this. For keyword in keywords, we are then going to see if the search term is in that keyword. So now if we just search for like climb, then we should find the mountain climber. And I guess if we do search words, it's going to be that and split with the space. Then we can do for search in search words, we're going to do this. So now we're going to search from every word and from every keyword and even inside of the keywords. So now if I say mountain climber, then now we actually find mountain climber. And if we search for a cat, we find, well, that's 2 times because there are probably 2 words that include cat in them. But this is just a quick demo. I hope you understand the point of this. Now, the second use case is what I like to call image laundering. So basically, if we combine GPT-4 Vision and the DALL-E 3 API, then what we can do is we can take an image file and pass that into GPT-4 Vision to get the description of that image. And then we can pass that description into DALL-E to create a completely new image. So for example, if I take one of these images here, what should I take? Let's take this motorbike image. So let's actually copy the path, and I'm going to run Python 3 image laundering, and I'm going to pass in this path to the image. Then now we are going to create a brand new image based on the description of this image. And it has been created. So if we open this creation.webp, then look at this. Here we have a brand new image made from the original. Well, only made from the description of it. So basically, if you find online some image that you want to use, but you don't have the right to use it, you can put it through this script to create a brand new image that is AI generated and has no copyright. Now, is this ethical or is this legal? I don't know, but it's super cool. So let's actually try another one. So which one should we take? Let's take that one. There's some cave paintings in there. So let's copy the path and let's run it through this thing. All right, and it has been created. So let's open this and look at this. Here we have a brand new image and it looks pretty cool. Okay, let's move on to the next example. So you can actually use GPT-4 Vision for web scraping. So basically what I'm doing in this example is I'm setting here a URL, which is the page I want to scrape. So in this case, it is an Amazon.com search page for Raspberry Pi. And then I take a screenshot of that site. And because I take a full page screenshot, and this page is very tall, then I use this image splitter to actually split it into parts. And then I send all those screenshot parts to GPT-4 Vision, and I say extract all the products and their prices from these website screenshots and return them in JSON format. And then I add an example of the JSON format. So if I actually run this, let's do Python 3 price scraping.py, then we get an error message. Sorry, something went wrong on our end. And this is because I forgot to turn on my VPN. All right, the VPN is now on, so let's try this again. And I wish I had a VPN advertiser right now, but I don't, so I won't tell you which one I'm using. And now we actually got a result. And here we have all of the products on the page. Now it might not be actually all of them, so this kind of web scraping is not as accurate as like a specialized one, where you actually look at the source code and then parse out the information. But we didn't have to check any like CSS selectors or anything like this. We just send the screenshot and that's it. Now the GPT-4 Vision API does not yet support the JSON mode. So actually there's some text up here and then we would have to parse the JSON out from this to actually use it somewhere else. Now another idea for web scraping that I had, but it didn't quite work as I expected, was this. So I created this website check and I pass in some URLs to some web pages. So right now I have running locally a WordPress installation. So this is the home page and then this is the contact us page. So basically we loop through all of these URLs and we take a screenshot of each of them. And then we save those screenshots to this original screenshots.json file. So we will have the URL and the file name of the screenshot. So let's run this. So now we are taking screenshots of those pages and we are saving them. And what I can do then is I have another script, which is this website check.py. It will loop through all of those original screenshots and it will take a new screenshots. And then we are going to send the original screenshot and the new screenshot to GPT-4 Vision. And we say, compare these two screenshots and check for errors in the second image compared to the first one. If no errors are found, respond with the JSON status OK. Otherwise, respond with the JSON status error and then details of the error. Now, you'd assume that if I now run this again, Python 3 website check.py, then there should be no errors because we are checking it again and it should work. It should be exactly the same. But what actually happens is we get an error. The phone number is different. In the first image, it is this one, and the second image, it is this one. But that is not correct. And sometimes it even complains about some repeated content or something. So this is not very accurate. But I bet you could do something about this prompt to make it actually work in some specific use case. So the use case I was thinking about was something like checking a website periodically to see if it still works just the same. Or maybe if you make some updates or you update like a WordPress plugin, then you could check your website for errors. But it might not quite work properly. All right, let's move to the fifth and final example. And this is pretty cool. So basically, I have this sketch2site.py, and you might guess what it does. So basically, we take an image file from the command line argument, and then we send that image to GPT-4 Vision, and we say, convert this sketch into a full professional HTML and CSS template using Tailwind CSS from a CDN. And I add the actual script, how to use it from a CDN, because sometimes it uses a CDN that doesn't work. And I say, respond only with the code. And then down here, with this marvel of a one-liner, we extract the code from the response, because it doesn't actually respond only with code, even if you tell it to do that. And then we just write that code into a file. So let's make a sketch and let's try this. So I'm going to go to Photopea and let's create a sketch. I'll just pick here YouTube thumbnail as the canvas size. And let's say that we are building a translator app. So this is going to be our application, and we have a header like this. And we should have some sort of boxes, kind of like Google Translate. So we should have like a box here, and let's make it some gray color, and we should have another box here, and let's add some text. So this box should say text to translate, and let's make this a bit smaller. So this is the text to translate, and then of course we are going to have translated text in this one. And I guess we want to pick what language we are using. So let's put here English, and then let's have another one here, which will be French. And let's write here that these are drop downs. And let's make this red. And let's make like a line. Let's draw a red line. These are drop downs. Both of these. And then let's add like a button for translating. So let's add here a button, and let's say that it says translate. Now it's in the wrong place. I have to put it here, translate. And let's make this white. And let's put it here. And let's make the shape some color, like blue, for example. Okay, I think this is enough of a sketch. So let's export this as a JPEG. Let's call it translator. And let's try to convert this into an application. So let's go here. And I will CP from my downloads the translator here. And let's run Python 3 sketch to site. And let's pass in translator.jpg. And let's see what kind of code we get. Okay, and actually we printed also the code. So here is the code that we created. So let's actually run xdg open the code.html. And look at this. Here we have our translator app. Now the translate button is not quite in the right place. It should be down here. But at least we have here source language and target language. And we can pick, although we don't have any choices here. But anyway, that's a pretty cool beginning of an app at least. And we can of course run this again. And we're going to have a different style of application. And let's open this again in the browser. And here we have another translator app. And this looks pretty cool as well. So we can pick here and then text to translate and translated text. And a translate button in the right place. So I think that's pretty cool. Do you think it's cool? let me know in the comments if you think it's cool. Now let's dig a little bit deeper into the source code. So how does this all work? So basically I have created this vision.py script, which basically connects to the OpenAI API to use the GPT-4 Vision API. So we just import OpenAI and we import base64 and we initialize the model. And then we have this function that takes an image path and then it just converts the image into a base64 encoded string. And then I have this look function that takes an image path and then it takes a prompt and then it converts that image into base64 and then we just send this request to the GPT-4 Vision preview. And in the content of this message, we add the image as this data URI that has the base64 encoded image, and then our text here, our prompt. And we just get the response text from this. So then I can call in my image categorization, for example, I can say import vision. So vision is my own module. And then I can just say vision.look. And then I give it the image and the prompt. And that's it. Now with the image laundering, I use DALL-E as well. So I also have a DALL-E module. So basically we just import the same things again, and I have a make function that takes the prompt and an output file. And then it just sends a request to OpenAI to the DALL-E 3 API, and we set the response format to base64, and then we just decode that and save it into a file. And then we return the output file. So then we can just import DALL-E like we're doing in image laundering, import DALL-E, and then we can just say DALL-E.make, and then we pass in the prompt, which in this case is just the description from vision.look. Now for the web scraping, we are actually using Node.js, but I do have this screenshot.py, which is just a wrapper for this Node.js script. So basically we take the URL and the file name and this full page argument, and then we run this screenshot.js with Node. And this always saves the file to screenshot.jpg, so then we rename that if we want to use a different name. And basically what we do in screenshot.js is we initialize Puppeteer, and we take all these command line arguments, and we launch a new browser, and we launch a new page, and we set the width and height of the page, and then we go to the page, and we take a screenshot. And also we have this set timeout here because sometimes the timeout happens here, and Puppeteer crashes when the timeout happens. So I set this timer so that before the timeout, we're going to take the screenshot. And then we're going to take it again if we don't crash in this line. And that's basically it. Oh, and I created also this multivision.py, which is basically the same thing as the vision, but here we can actually pass in a list of image paths. So then we are going to send all of those images in the same prompt to ChatGPT. Now, I could just use this for the regular one because this takes a list and just a string, but I thought that this might look more intimidating than the simple version. So I made a separate one. And then, of course, I have my image splitter, which you might see that I created with ChatGPT. Now, I did some changes to this because I wanted to add this offset here. So basically, we take an input image and then an output folder and a piece height and then this offset. And then we open the original image and then we clip it into pieces vertically so that all of the pieces will be the piece height. And then we offset them a little bit because sometimes the screenshot is clipped in such a way that like a product box is cut in the middle. So then we will have it in the next piece. So that's basically what this does. Pretty simple. Now, I also have another project which I have posted a video about, which is this GPT-4 Vision browsing, in which I'm creating a program that can actually browse the internet with GPT-4 Vision and actually click links on the page and follow them. And I have one video about this up already, so if you want to see that, then you can click the link in the description, or maybe if I remember, I will put it somewhere up there. And of course, don't forget to subscribe to my channel if you want to see more videos like this in the future. and let me know your comments. What should I build next with GPT-4 Vision? Thanks for watching, and I will see you in the next one.